Good morning, good afternoon, and good night, no matter where you are. Welcome to our sessions. I'm Dr. Long. Mr. Si will do the presentation with me. Our paper title is Content-Inspired Genetic Algorithm for Sustainable Logistics Management. We will use about 20 minutes of time for the PowerPoint presentation, followed by 10 minutes QA sessions.
Hello everyone, my name is Yi-Cheng Shi, and this is our agenda, including introduction, research methodology, experiments, and conclusions. And first, I will introduce our research background. Global warming and climate changing are ongoing issues right now and require immediate attention around the world. They are related to the emissions of greenhouse gases into the atmosphere. And according to the Institute for Environmental Analytics, global temperatures have increased by over 1.2 degrees Celsius in past 170 years. And one of important observation during the pandemic of COVID-19 is that many regions have been locked down for several months. And at the same time, the pollutants in the atmosphere also reduced around 9 to 64%. And it is obvious that human activities have significant influence on the amount of the pollutants in the atmosphere. Therefore, how to reduce the emission of greenhouse gases during our daily life and industries has become an important issue. And then I will talk about sustainable logistics management. If we have an inefficient logistic management, what will happen? Our trucks will travel for a longer distance and consume more fuel. And of course, it will cause a lot more greenhouse gases like carbon dioxide or other greenhouse gases. And pollution routing problems, PRP, is one of the variety of VRPs, which aims to minimize the amount of pollutants produced during the delivery process. So our research objective is to solve the PRPs, which aims to minimize the CO2 emission during the delivery. We also propose a two-phase hybrid model to solve the PRPs. The hybrid model combining clustering method and content-inspired genetic algorithm, QIGA. And this is our problem proposition. We focus on the problem having single depots with a capacity constraint of each truck. When the decision variable xijk equal to 1, means that vehicle k is in the true from node I to node j. And in this research, we assume that the amount of emission of CO2 has a linear relationship with the total weight of the truck, which is the sum of the demand's weight and the vehicle's weight. And the objective function is to minimize the accumulation of CO2 emission for each route. And here are our constraints. And these two are to make sure that every customer is served by one and only truck. And this one is for the route continuity. And this one is for the capacity constraint, and these two are to ensure the truck's ability does not exceed, and the last one is to eliminate any subtool. And here are our notations. And the first phase of our hybrid model is two-stage clustering method. And we first use the sweep algorithm to generate the initial k-centers of weight for each cluster, and then integrate these initial k-centers of weight into the k-means algorithm with capacity constraint, and then use the k-means algorithm to dispatch the customer to k vehicles. And this picture is an example of our clustering method. And the second phase of our hybrid model is content-inspired genetic algorithm, QIGA. The QIGA, the process of QIGA is similar to the traditional GA, and also containing with initialization, evaluation, selection, crossover, and mutation. And in this research, we choose integer representation to represent our DNA sequence. And first is initialization. In the initialization, we do the parameter setting and insert the sequence that was the result from the clustering process. And then we randomize the initial sequences several times to become the initial population. And for evaluation part, we evaluate each of the populations through its finished value. That is, we input the DNA sequence into the objective function and then output the finished value. And for selection part, we use the modified roulette wheel method to choose the parents for the crossover part. And this is the probability of being selected for each individual. And then I will introduce our crossover part. Traditional GA has only one crossover method to produce offspring, and which means that each individual can only search for the solution in one dimension for each iteration. In our research, and we develop a new crossover process, and we introduce 4 different kinds of crossover method, and the probability of being selected is related to the offspring's finished value produced by the method. So it means that our model 重新走
Continue.
continue 啊，therefore, each individual can search for the solution in 4 dimensions, and which is, for each iteration, which is inspired by the quantum computing, that each qubit can search in multiple dimensions or even infinite dimensions. And then I will introduce 4 different kinds of crossover method in detail. First one is partially mapped crossover. Partially mapped crossover will randomly choose a sequence of elements. For this example is from the 4th one to the 7th one, and then exchange the element from each other, and then preserve the relationship between this position, like 4 and 8 and 5 and 2 and 7 and 5. And then we can find that there are some repeated parts, and we will fix the repeated part from the relation we have stored, and then we will get the offspring. And the next one is order 1 crossover. Order 1 crossover will also first randomly choose a sequence of elements and preserve the elements, and then input and then fill in the empty elements with the other parent's white part, For example, parent 1 will fill in the empty parts with the parent's y part 1 and 4, but 4 is repeated, so it comes to the next one. So it's 1 and 9 and 3 and 7. And the third one is cycle crossover. Cycle crossover will first randomly choose a start position for the parent 1. For example, parent 1 will choose first position as a start position, and then the next position will according to the element of the mapping position of parent 2. In this example, the one will map 9, and 9 will choose the next position for the parent 1, and 9 and 4 and 4 and 8, and continue the process until the cycle occurs, and preserve the elements in this position and exchange the others, and we will get the offspring. And the last one is modified order crossover. Modified order crossover will first choose a split point for the sequence and separate the sequence into gray part and white part. And for this example, parent 1 will preserve the element that is mapped with the gray part of parent 2, 3, 7, and 8 and 9, and then fill in the white empty part with the white part of the parent 2. So it will be like 2, 6, and 5, and 1, and 4. And we will get the offspring. And for the mutation part, we will first generate a random number from 0 to 1 and compare to the mutation probability we have set. If the random number is below or equal to the probability, we will do the mutation process. In this research, we apply a two-point exchange method to complete the process. That is, randomly choose two positions of the sequence and exchange the elements of the position, and we will get a mutated offspring. And all the randomness in the QIGA are generated by the quantum random number generator QRNG, and we use the R package. We use the R function Q random unit function to connect to the Australian National University QRNG server, and the server will access to their QRNG to return the true random numbers and integrate into our QIGA. And this is a quantum technology timeline. And with the development of quantum mechanics research in recent years, and quantum technology has been applied in several fields like quantum sensing, quantum information processing, quantum communication, quantum computing, and quantum computer. And the quantum random number generator we have used is in the quantum information processing field. And QRNG can provide a true random number because of the inherent randomness of quantum system, and make the quantum system become a perfect source of entropy. And then I will talk about our experiment. We use 30 different kinds of instance, including set A, set B, and set E. And for each instance, we ran the test for 30 times. And after finish the DOE, the parameter setting is as following. Iteration per run is 10,000. Population is 100. Crossover probability is 0.95. Mutation probability is 0.025. And here are our research table. And the instance name is like this. A and B and E represent the set which set of the instance to belong, and N represent the number of the nodes, and K represent the number of the vehicles. And from the results, we can find out that our model can provide good solution with small standard deviations. And these are the best routing problem for our model. And then this instance has 22 nodes and 4 vehicles, and then this one has 76 nodes and 7 vehicles, and we can find that the models can produce fair solution quality for small scale problems or bigger scale problems. And sometimes there are some cross intersection that should not occur in traditional TSPs, because our objective function not only consider distance but also the total weight of the vehicles, and which means that those customers having less demands may have a higher priority to be served. And then is our conclusion. And in this research, we proposed a clustering method that is a two-stage clustering method, combining the sweep algorithm and k-means algorithm with capacity constraint. And then we use the proposed quantum-inspired genetic algorithm, QIGA, to do the optimization. And then after the experience, we find out that the hybrid model provides good solution quality with small standard deviation. And CO2 emission minimization provides lower fuel consumption and smaller environmental impact, to follow one of 17 sustainable development goals set by the United Nations. And thank you for listening.
Okay, that's all for our presentations. Next, we will go to the Q&A sessions. So if you have any questions, just push the raise hand button, or you can type your questions in the message box.